Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. Today we have to start looking at our lighting system to see how we can improve its actual runtime performance, and we have a lot of ways that we can do that, but we're only just starting out. What we did was we took the first step of making it so that the light tracing that we were doing before can be done via a spatial hierarchy now. So already just from that one change, which is a performance-oriented change, but it wasn't really ever measured in terms of performance or anything like that. It's not really a targeted optimization. It was more just okay, we know we're going to need a spatial hierarchy to begin working with these things in some way that will speed them up. But even just from that, we already got to the place where an entire level-sized chunk of the game being lit, the whole thing being lit with full ray tracing on right now, is already doing reasonably well. Now, it's not quite representative, so we have a little bit more, we have more stress we should put on this eventually, and so we're not really quite done knowing exactly how slow it would be. It'd probably be, again, a bit more slow. The reason for that is because these trees here are currently not being lit. When we turn on lighting for like the trees and entities, we're gonna, I don't know if we'll quite double, but we'd be more up in the 200 milliseconds per frame. So obviously we're only getting something like 5 frames a second probably in reality here, which isn't bad at the outset, but obviously it's a long way from where we need to be. So what we need to do now is start looking at how we're going to make this stuff work in terms of running at a reasonable frame rate. Now, there's a couple things that you can see here. One is that we really need to probably cull what we're actually lighting and what we're not. So if you look at how much of the world is being simulated, we simulate much more of the world at a time than we really need to see. The reason for that is we wanted to potentially be able to have it so that when you're looking at a particular area of the game, a wider region would be simulated so that stuff that happens off at least one screen to the side would still potentially affect what you were doing. So for example, if a monster was chasing you from the previous screen and you hopped onto this screen, we aren't sure yet necessarily, but we were considering that maybe we want that to be something where the monster could follow you over. And if all we ever did was when you move to another screen, we just only simulate the screen you're looking at, you can't have really anything dynamic like that occur. So the idea here was that if the world consisted of a path that looked like this that you had traversed, maybe we still simulate some number of screens to the side, because the simulation probably isn't very expensive at the end of the day, and we can afford to do more of it. Okay? So that's really all we were thinking of doing here, and given that, it makes sense to have all this stuff pulled into the system. What doesn't make sense, however, is us actually processing these things for lighting, because what you can see is that the lighting that happens over here is never really going to affect the lighting that happens over here, and even if it was going to affect it, we don't have to capture that, right? We're still going to get good lighting by just doing here. The user's never going to notice the error, because they're never going to even know there was a light over here, really. So in terms of visible error in the system, that's just not something that realistically is going to occur. And so at that point, it really doesn't make sense to have this much stuff in there. So what we would like to do is more aggressively cull what is and is not a part of the lighting solution, so that we're not even lighting the stuff here. And that will drop our frame time down quite a bit just in and of itself. So I think we want to do that before we do anything else for sure. But then in addition to that, we're going to need more techniques here, and those techniques will probably revolve around how we build the spatial hierarchy and how we process the spatial hierarchy, because right now we're doing the simplest possible thing, which is just building a basic spatial hierarchy and raycasting against it, still using the exact same methods we were using before with no modification. So I think we can improve on that quite a bit anyway, and we're going to take a look at that as we go forward. So let's start with introducing some basic culling to the lighting system, so that the lighting system is not actually going to process anybody who's too far outside of the lighting bounds. So what I'm going to do here is I'm going to go ahead and I'm going to load up the Handmade Hero project, and we're going to go and look at the rendering right here. So what we want to do is we want to go ahead and take a look at where we're actually pushing this lighting on. And what I would say is when we do a push cube to push lighting on, I think what we want to do is get rid of any lighting that isn't inside a light bound, and I think we want to do that right away. So meaning all of this work that we're doing to push on lighting in the first place, while that may get simpler over time as we optimize this more, it's still work. And so the two ways that we could attack this problem, one, by just never pushing on stuff that is outside the light bounds, and two, by culling things afterwards, by looking at everything and only processing things that are in the light bounds. I think we want to go with the one that just never puts them into the lighting solution at all. And the reason that I think that's a good idea is because that way it just never even generates the data traffic, right? If we can cull earlier rather than later, that seems like a better solution. So I'm going to start by trying culling early, and then if we find that there's problems with culling early and we really need to cull later for some reason, we can always switch to that. So I think that's how I would like to do it. So in here we see we have light index store. What I'd like to do is say, well, when we have light index store going on, what I want to do is say, okay, if we weren't going to use this light because it's out of bounds, what I could do is just check right at that head end. We know that if I don't enter this light index store branch, then it doesn't push the lighting, because we already have the ability to specify that you don't want lighting when you put something down here, right? So all I have to really do is say, if I wasn't going to get any lighting on this guy because he's out of range, whatever it is, we could just put a nest inside here. Excuse me. We could just put a nest inside here, like so. And what I could do is check the bounds, like in light bounds here. If we're not in the light bounds, then I can just overwrite that light index store with zeros here. So basically when this is being passed in, you can kind of see here we have light index store. It's being passed in as a 0 here. We know we need to sort of clear that out. Light index, the light count here as we have it, right, is 6 times 4. It's 24 of these, right? So what we can do here is say, all right, if we're going to do, we can just do a 0 size here and say we're going to do, 6 times 24 times size, size of star light index store. We can just say, look, we're going to clear out all of that. So if anybody was previously getting lighting at this location and now they've moved out, we're just going to clear it. You don't get lighting anymore. Sorry, my friend. Okay. And we may need to work on that and make that more efficient depending on the circumstances and blah, blah, blah. But for the most part, right, this is all we really need to do. All of this stuff here is going to get cleaned up a little bit because remember, we're going to have to put in a little like light slot allocator for a number of reasons. And so that's going to be sort of a separate issue there. Anyway, so this is what we're doing. And so what we need to do now is just figure out a way to test whether it's inside the lighting bounds. What I want to do for that is, you remember the render group has lighting enabled. What I'd like to do is, in addition to say lighting enabled, I'd like to have a rectangle 3 in here, which is like light bounds. And so what I want to do is say, once we get one of these cubes, we effectively have knowledge of its min-max, right? We know where it is because we build that right here, right? So if we wanted to, we can build a rectangle. And we could say rectangle min-max 3. I assume we have one of these. Something like that. I can specify the min corner and the max corner, and then I could say if, intersects at all, the cube bounds with the, what did we call this in this routine? Group. With the light bounds. So if they intersect, then we know that we'll push a light on. If they don't intersect, then we're not going to. Regardless of whether they told us we want lighting or not, that light bounds is going to, magically make the lights disappear if they're outside. Okay, So, and remember, when I say light bounds, I don't literally mean the boundary for things that are illuminated. I mean the boundary for things that participate in the lighting solution. So even just opaque objects that do not emit light but are receiving light, those are also discarded. So the only things that go into the lighting solution are ones that are in this box. So what I need to do here is I need to make sure we have these functions. I don't know if we've done much with rectangle 3. So let's take a look. We've got a few functions here. Let's see what they are. We have the rect min max, which we need. We have a point test. So here's what we need. Rectangles intersect. So in here, we just need to say, all right, if the rectangles intersect, then it's inside, and off we go. So if we were to run this, oops. If we were to run this now, what I should get, hopefully, what happened here? I was definitely not expecting that. Did I clear too much of my light? Oh, this just stores the first one. Never mind. That's actually great. Light index store can now just be cleared that way. I thought it stored the whole range. It doesn't. That's fantastic. So what should happen now is we should get no lighting on most of these things, right? Or all of them, because we have a light bound that doesn't actually appear anywhere, right? There is no light bound at the moment. So what I should be able to do is I should now be able to set that light bound to be something relatively small that fits on the screen, and we should be able to see the lighting only occurring inside that boundary, right? That's what we should be able to see. So when we call enable lighting, what I want to do is have a rectangle 3 here that's like, all right, the rectangle 3 is the lighting bounds. And when we do that switching of it on, I'm just going to set it there. So the light bounds are set here. I also want to just take a look here. I assume the way this works is that lighting it, yeah, there it is. It'll just clear that out, like so. So if lighting's not enabled, it just ignores that part of the function. I don't know if that's the way we want to do it eventually. Maybe we want to clear the thing as well. I'm not sure how that wants to work eventually. Oops. But we'll deal with that a little bit later. Okay. So if we want to just have the same thing as we were doing before, we have the simulation boundary we could pass there, and that would do lighting on everything, right? So the sim bounds, for example, I believe, are all we would need to do the entire world. That's what we were doing before. So if I pass those, I should see everything in the world get lit now. Let's see, that looks about right. You know, so you're getting all of the stuff in there. We definitely still have some bugs, by the way. Like, I remember looking at this at the end of last stream. There's a couple things that look like they're not getting processed properly. So that's going to be something we're going to have to look at. But anyway, when we do enable lighting, now that we pass the sim bounds, we can choose to shrink those down to be much more tight, right? So they don't have to be the same size as everything else. So for example, the standard room dimension, which tells us roughly where we're at, if I wanted to, I could set the sim bounds. I could take that standard room dimension and I could change how we're computing the size of it, right? So I could say that the light bounds, for example, like so, are going to just be, you know, a smaller size increase. I could also say that since you can see the whole Z range, I could make it so that the whole Z range does participate in it. So for example, the light min Z would equal the sim min Z and the max as well, something like this, right? So we have the ability to change that now, and we should be able to now more tightly bound where the light computation is actually going to occur. So if I run the game, you can see we got quite a speed increase just from doing that because, hey, there's a lot less stuff actually involved in the lighting now. So let's pull back and we can see now like all of this stuff out here no longer participates in the lighting solution and doesn't need to, right? Because this is plenty what's getting simulated here. There's definitely no need to simulate anything more than this range. In fact, we could probably do less. So we could probably even go a little bit further along those lines and say here that maybe we only need 1.0 times the standard room dimension there, and that would be sufficient. So if we take a look at this, now we're running at a good 30 frames per second there, not quite 60, but you can see that the lighting solution kind of stops there. So when we're looking at it here, that's probably reasonably good. It's not quite right, but... So we can also see now, I'm glad we can see this bug a little bit better. So if I run the game now, one thing that you can see is I'm getting buggy behavior from this light. So it's affecting stuff that's not, it's sort of getting some weird light wraparound behavior. So we definitely have some bugs in here in how we're processing the lighting that we didn't have before. When we move to the spatial hierarchy, we're getting some kind of a weird like spillover effect that's happening there. So we need to go track that down as well. It's going to be something kind of separate that has to do with our enumeration. It has nothing to do with the light bound stuff we just put in. It was in there at the end of last stream before we ever started mucking with that. But you can kind of see it happening, right? Like you can see that this stuff over here should definitely not have this light source involved with it at all, but it's getting it, right? And so what's happening there probably is we've got some index behavior that's going wrong, or something weird is happening where somebody who should be getting light over here, or some computation that would have been happening over here is actually writing to lights that are over here, or something like this, right? So that's, what we're looking at there. Now, the other thing I want to point out here is just that change by itself, though, considering a smaller region, has already gotten us into striking distance in terms of running this at a fast speed. And so if we were to imagine moving this to the GPU or multi-threading this on the CPU, we're basically done, right? This is fast enough now. So we'll have to double check because we'll have to actually see. I don't know at the moment, for example, I don't know what the speed is like in terms of if we actually have everything running that should be running. And furthermore, as you can kind of see, moving here slows us down because now there's more stuff on either side of us. So we really need a good test case. We should probably make one where there's stuff all around us so we can see how we would actually be getting, like this puts us back into kind of a not so good range, right? So when we get more stuff happening, we still looks like we have more work to do, right? So we still have a little bit of a ways to go there. So we probably need to do a little more work with that, et cetera, et cetera. But again, still think we're in pretty good shape here because we haven't really begun to really push on this stuff performance-wise, and so I think we're probably not going to have too much trouble getting this to somewhere we want to be. But like I said, first things first, we got to start debugging this stuff, and we haven't even really drawn what's going on in any way yet, so we don't really even know how our spatial partition is working. We did kind of a pretty arbitrary thing to get our spatial partition working. We don't even really know if we built one that's any good. So obviously we've got more work to do there as well. Okay, so the first thing I'm going to do now that we've fixed that and we've got the ability to sort of limit our lighting to only things that are potentially going to actually be seen by the player or noticed by the player, which is the only thing we really need lighting for. What I'd like to do now is go into the lighting calculations and start to figure out how I could debug these, because they're going to be very hard to debug because lighting is a very nebulous sort of thing. It's pretty hard to know what's going on there. So we're going to have to think of some creative ways that we can debug this. Excuse me. I'm a bit stuffy today, as is often the case. I think I'm sort of allergic to everything, but only slightly. Not in the I almost died from a bee sting kind of a way, but in the like, I'm always a little bit stuffy. All right, so what we want to do here is start to take a look at what our lighting is actually doing and figure out how we could start to debug some of the pieces of it. Now, there's two distinct aspects of this lighting that can have bugs, and we need to come up with ways of visualizing both of them, probably, if we want to do this well. The first thing that can have a bug is the placement. I'm going to do the opposite of the thing I did yesterday, by the way. My feet are now too hot. This is the eternal problem, so I have to take my socks off in order to cool them down. Remember yesterday they were too cold and I had to put socks on? Well, today I had to do the opposite. Anyway, so what we need to do is we need to figure out ways to attack two different kinds of bugs. The first bug that we have is we've got this system where lighting elements are enumerated relative to certain like larger cube elements, right? So we have cubes. They're not really cubes, they're boxes. They don't have to be equal width, height, and depth. So we've got these boxes, and the boxes are the things that actually get raycast. So when we raycast, we just raycast against a box. When we hit the box, though, we then go ahead and look at what lighting, like individual light sample points scattered around the box on the surface of the box. Although I guess they don't really even have to be on the surface of the box if we don't want them to be. They could even be set apart from the box or other weird things like this. But the lighting points that are, for the moment anyway, scattered along the surface of the box, those lighting points are enumerated relative to the box. So every box has a list by saying what the first light sample point is, and then there's a count of how many light sample points there are. That process itself is one that can have bugs in it separately, right? So that alone, the correspondence of boxes to sample points, that could be buggy. It can't be so buggy that it just doesn't work at all, because we are seeing some lighting that makes sense. So it's got to be at least somewhat working, but it could have plenty of subtle bugs, like let's say maybe it writes too far over, and so we're filling more than the number of light sample points and blah, blah, blah. We wouldn't get crashes in those scenarios because we pre-allocate a big block for our lighting samples and we don't use all of it. So we could do a number of simple things already. We could start to assert on bounds and make sure that we don't overwrite and stuff like that. So we can already start to put some things into place that would try to make sure we're not doing anything weird there, and stuff like that. So we can start to attack that problem. Just, are we properly corresponding our lights with their boxes and so on? Is that happening at all? And are there bugs there? So that's one source of bugs. Another source of bugs is the back assignment of them. So that's a source of bugs, is just the process, like the actual handling of those light samples inside the lighting routine, right? You know, I should probably just write these down because I'm about to enumerate a bunch of them, and then we don't want to forget them as soon as I say them. So let's just go ahead and pop Milton open here. So what we want to do here is we want to say, one, are cubes, or I'll use the term boxes and sample points correctly attributed to each other in the lighting solution. 2, are rendered elements, so the quads, picking the correct sample points. Because remember, once we compute the lighting solution, we now have a set of lighting points that are scattered throughout the world. And there's a number of different ways we can use those lighting sample points. One way to use those lighting sample points is to do something like putting them in a voxel, looking them up spatially, inside the actual rasterizer, right? And I decided I didn't really want to do that because it's a little bit too error prone in my opinion. What happens when you do that is you have to have good ways of knowing whether or not a sample point is actually valid for the surface that you're talking about. And a lot of times it becomes very difficult to be able to determine whether it is or it isn't. And there's entire sets of graphics research papers, believe me, tons of them, based on lighting reconstruction from sample points, and there's lots and lots of artifact issues, lots of them. And you end up doing a ton of work to make sure you don't get artifacts. And I don't really want to do that if I don't have to, right? Because it costs both development time that we'd spend developing it, but also potential artifacts that maybe we never get rid of or that you can't get rid of at runtime and blah, blah, blah. So there's a whole sort of rat's nest there that I just don't want to get into. So we manually correspond ours. When we build the world, we say which sample points are going to be used for interpolation for any given surface. And I think that's great, but it means that we end up in a situation where we have to make sure that we don't have bugs in that correspondence, right? So in addition to the first part, which is inside the lighting solution, when we're actually doing our light tracing on the boxes, are we actually using the right points every time we hit a box? Are we putting the light in the right place, those sample points? That's error possibility 1, but error possibility 2 is that when we go to pick which sample points to use for a given quad, are we picking the right ones? So there can be an index mismatch in either case, and we need to make sure that we're not having that, right? Because either one of those is a bug, and they're two separate kinds of bugs that could occur even though they're similar, right? So then we have number 3, which is, I guess, I'm not sure how to write this one because I'm not sure how to state it too succinctly. Let me try to say it first, and then we'll see if something jumps out that's an easy phrase. So when we move to using a spatial hierarchy, that act of creating the spatial hierarchy and traversing it, if there is a bug in the traversal of the spatial hierarchy that somehow produces erroneous results with hit testing, we may falsely attribute a light hit to a box that never actually got hit. So, false light interactions, or let's see, are there false light interactions occurring as a result, don't know what just happened there, as a result of the spatial hierarchy traversal. So we've got these 3, and these are basically bookkeeping errors, right? So chances are we don't have a lot of problems. I mean, we might have raycast. In fact, I guess I should write this one down. Is the raycaster producing correct box intersections? So that's obviously another separate issue. We might be having something where we're getting spurious intersections that are not right. So the algorithm's busted and it's producing the wrong results. So these are bugs. They are correctness bugs. And we have to look at those. Those are just terms in terms of getting a proper lighting solution. We've then got another one, which is the spatial hierarchy properly constructed? Because if we've got bugs, this would not produce a correctness bug. This is a performance bug. Let's say, for example, we thought we were producing a spatial hierarchy, but actually we still included tons of boxes in various nodes of our spatial hierarchy that didn't need to be there. If we did that, we would easily end up in a situation where we weren't getting as much performance from our spatial hierarchy as we should have, even with no modifications to the routine that uses it, simply because we're over-including boxes that just don't need to be in various nodes. So that is a kind of bug you can have that doesn't actually produce incorrect results. We could put every box into every node of the spatial hierarchy. It would run awful. It would be very slow, right? But it would still work just fine. There would be no errors in the resulting routine. So there's definitely two classes of bugs we can have inside a routine like this. One type of bug will actually produce incorrect results, possibly subtle that are hard to notice, but that are incorrect, or blatant, like the one we have right now, where it's clear that there's light going to areas that shouldn't have light in them. So there's two kinds of bugs we can have there, certainly. But then there's, this other kind of bug that isn't about correctness. This is about actual performance, where it's like the bug doesn't show up in any visual sense. The only way you would know it's there is that maybe your performance is worse than you think it should be, but more importantly, when you go to investigate, you see somehow, you create some way of visualizing the spatial hierarchy, and you can see, oh, wait a minute, this is supposed to only include the things in this area, yet all of these other things are being included. What's going on, right? So that's a very different kind of bug, but again, it's the same kind of bug for purposes of this investigation, which is that all of these are things that would be pretty hard to find without instrumenting our code in some way. Like, just looking at the results isn't really going to be able to find these kind of bugs. The best we can do is, for really blatant bugs like that lighting one, kind of see that something's off. But it really, looking at this, right? Even sort of knowing that issue that we've got there. So here is a bunch of light coming into this corner, right? And here is where the light actually is. Now, there's no way that those two things are getting that light. It's pretty clear that they're acting like they're sitting over here, getting light from what these guys are getting light from or something, So something's obviously up there. But just looking at that, I have no idea why or how, right? I just don't know. There's no... I can tell it's probably an index issue, maybe, because it's like... It seems to be kind of regular, right? Like, you can see it strobing through as I move. So it looks like we've probably got an index error where, these things are getting light from these indices or something. I can tell something's up that probably has to do with indices, but I don't really know, and I don't think it would really tell me much about the circumstance, right? Or how to find it. So I can go double check the index code. That's about all I can do. So again, we're really going to need something that shows us more information here. So one thing that we can do, and probably the first thing I'd like to do after, I'd like to go just check the code just by inspection and get rid of any bugs I can just find by looking. After we do that, what I'd like to do is say, okay, let's try to figure out some ways of maybe like we can pick a lighting element or pick a voxel, a bounding box in the spatial hierarchy, and let's draw it and draw its children and its light sample points, so that we can just say, like, look, okay, just inspection-wise, does any of this stuff even look like what we think it looks like, or is it just borked? Okay. So let's first go through and take a quick survey of the code, and then let's start trying to focus on a way we can actually get some kind of a light debug sort of inspection going on. Time to switch to coffee, from coffee to lemon water. Everyone knows it's time for that, so I won't even belabor the point. Okay. So let's just start with the basics here. The pushCube function takes the light index store, and when you pass this light index store, it's expecting to have the light index store written back into it. So the only thing it knows is where the light index store starts, and that's fine. If we're going to write into the light index store, we can kind of see here that we pick a light count, and we know that the light index is going to get advanced, right, by 6 times the light count. So in here we say, all right, the light index equals the light index store if we previously stored one. If we didn't, we store where we were, and we essentially allocate one out of here. Again, this is a to-do because we have not really done the roving allocation of the light sources yet. That hasn't been something that we've actually done yet. It's something that we need to do. And so that's, again, something that, and for all we know, maybe that's already causing a bug, right? We don't really know. We don't really know what's going on there yet. So what we want to do here is, you know what, and in fact, now that I'm looking at that, that does look like something that, I don't know that it can cause a bug yet because we're sending down the same things all the time, but it could cause a bug when things are coming in and out of the set. Now that we do cull things, this actually could potentially cause one, I think. So I think we may actually need to address this now. This may be something we want to actually fix. So I'm going to go ahead and say that that needs to get addressed. So let's take a look at how this is working here. Inside our platform layer, we sort of have the notion that we've got some number of light. Let me go ahead and jump to there. Oh, you know what? We pulled it out in here. We have a notion that there's a certain number of light indices that we can work with. So right now we're dealing with about 16,000 light elements, right? That's how many you can have. And so when we write back data, we can have that many of them. So what we want to do here is we want to be able to allocate these responsibly. Just like dripped something onto my keyboard. Oh well. So what I want to do is I want to be able to process these in some way that allows me to sort of do a fixed size allocator kind of a thing on top of them, right? So inside here where we do our lighting solution, and I've got information that I'm working on where I say like, all right, I've got sort of my, my lighting solution which persists over time, and we do the averaging and so forth in here. What I want to do is have a way of knowing how these things have been allocated. You know, I need some way of tracking what is and is not used. So what I need to do for that, I think, is I need to just have, exactly as it sounds, sort of a thing that like partitions these light points into blocks that I hand out. And then when someone doesn't use it anymore, I actually have like a free store that just tracks them. And this is very easy. We've done this a lot of times before, and it's pretty trivial for me to put in something like this. What I'm going to do is I'm going to say that we've got essentially a first free lighting point. Here's the lighting points here, right? And what I'm going to do is I'm going to track this in here and say first free lighting point, like so. And what I want to do is I want to make this as fast as possible in on any particular frame. So at startup, I'll probably seed it so that it's set up as a free list that goes all the way through. And then from there, it'll always be a free list for always, right? So let's take a look at how that would work. What I want to do here is say, okay, when we do this if on the index, on the light storage, what we're saying here is if we already are saying here is the light index we want to use to store this, then that's great, we will use it. If this one doesn't have it, then what we have to do is pull one off of the free store. So we need to have the lighting solution available to us, right? That needs to be something that we can bake in there. And we'll figure out how we want to do that later. It doesn't actually have to be stored in here. It doesn't really matter where it's stored. It could be stored in the command list, for example. So, you know, we could, if we want to, inside here, right, we could store it. So it doesn't really matter where it's stored. This might be the better place for it because this is the thing that persists frame to frame through the platform layer and the OpenGL. So it's probably a little bit more appropriate to put it in here. So anyway, inside here we could say we've got a lighting point, which we're going to use to track what the first free lighting point is. And then inside the lighting points here, these are things that get pushed on, right? You can see them getting pushed on like so. And this is tracking the maximum light index. What we want to do is now stop that entirely. So instead of having a light point count here, we're just not going to do that anymore. We're going to get rid of that probably and say we don't have a light point count anymore. We just don't know how many there are. There's just an array of them or something like this, right? And we assume that the array is the proper size that has as many as need to be there, right? And again, the lighting point is one of these things, a reflected color, a normal, and a position. Okay. All right, so when we're looking at this thing doesn't need to occur at all, although I probably should leave in this part where we just assert that we're not writing outside of the bounds of the legal size of our light solution. But that's it. Okay. So now there's no more concept of the light point count. We just have a giant block of them, and they get allocated as however they get allocated. That's just how that works. So then when we come through here and we have our light index store when we're rendering these things, we sort of have a bit of a tough problem. And allocation is easy. We just pull something off the free list. The hard part is knowing when to put something back onto the free list. That's actually very tricky. And the reason that that's tricky is because we don't know ahead of time what has happened to the people who previously were holding light indices, right? We don't know whether they got used or not. So in order to track whether they got used, there's a number of ways we could go about this. And I'll do the dumbest one first, but we need a pretty good way of handling this. So here's the way I would look at this. Let's go ahead and say that when we talk about the first free lighting point or things like that, let's actually introduce the concept of a lighting slot, essentially, or a lighting chunk. And a lighting chunk is going to be basically a package of lighting points that are, you know, like 24 or whatever, like lights, you know, we're going to have a number that you allocate at a time. So you can allocate more than that if you want to, but you have to basically deal with them in terms of these 24 wide chunks or something like that, right? So in here we would have this notion inside the lighting routine that maybe we say, all right, the light chunk size or light points per chunk is 24, right? I don't know where light count gets, okay, so it gets used here, like so. That's fine. So this is going to be light points per chunk, and this is going to be light points per chunk divided by the number of faces. So in this case, right, we're just talking about saying this is how these things are going to get allocated. And when we allocate them, what I'm going to do is the light index store. This is actually going to be something else. It's going to be the light chunk store, which is just saying here is what block I'm storing this thing in. So when I look at the light chunk store and I look over this, instead of assigning this to a particular, instead of looking at the light index as being exactly what's stored here, instead I'm going to say that whatever we get out of here is going to get multiplied by the light points per chunk. So essentially, I'm talking about keeping 24 points for every one slot we're actually tracking. Because since I know we want to give out these lights in quantity, because they get scattered all over a particular cube or something, I don't want to track each individual light point because that's just a waste of bookkeeping, I want to track a whole block that I give out at a time. So when I give out a whole block at a time, I give out light points per chunk worth of that block. So then what I want to do is say, all right, if I needed to allocate a new one of these, then what I can do is like look at whatever the first free one was. And that's, again, pretty straightforward. So what I can do here is just say, all right, I've got in my lighting platform code, I've got my first free lighting chunk, and that's the thing that says where I would get this from. So I'd say my first free lighting chunk, the light index store is going to get that. So maybe I'll do if it doesn't already have one, then give it one, and then assume that if we can get one, we will use it, and if not, we won't, right? So we kind of want to do something that looks like this. As we sort of push forward a little bit on this. So what I want to do is say, all right, if we ask for lighting at all, then we're going to start doing the lighting. If we actually intersect the light bounds, we will process it. If we don't intersect the light bounds, then we're just not going to process it. We then go, okay, the light count is going to be fixed for now. Still, we're not assigning multiple different numbers per cube yet, although we could, right? And then we have this light index store where we're going to store the light index here. If there was no lighting last frame for this guy, then what we'll do is say whatever the first free lighting chunk is that we've got, we'll give it to you. Then what we'll do is say, well, if this was actually valid, right? If this actually had, in fact, we could do the if here before we even do the assignment. If this was actually valid, then whatever is at light index store's position, right? This for the lighting point, we'll assume that that stores the free list on top of the existing data. So when you are not used, this is effectively, a union here. So normally you can access P, Ref, C, and N, but in the case where this is not a real lighting point and it's actually free, then we will just store the next free pointer there. Okay? So in that case, we're going to look up into the command structure. Where is that? Here. And this is how we will pull out that information. We'll say, all right, the next free chunk that we've got is going to be whatever the light points were to begin with. We expect the next free one to be stored in there somewhere, like so. So that's it. That seems reasonable to me. And that'll just allow us to recycle light chunks as they are freed. If we don't get one, that just doesn't get lighting, right? And so what we can do here is also place an assertion in here. And so this way, at runtime, if we did hit this in the actual game, you would just get something that didn't get lit, which is not a huge problem. It's a visual bug, so we don't want it to happen, but it's not the end of the world. So we still handle that error, but in debug mode, we'd like to know, because ideally we would never underflow. We'd always have a big enough array that we never have scenes with so many things in it that it blows out the lighting size, right? So then we go through here and we say, all right, if we got our lighting index store, so we can actually process what we're doing here. And I guess, to be fair, we've already done that if. So really that just goes in here. So we don't really need this if anymore, I suppose. Oh, well, not really, because this is only in the case where we tried to allocate. So assuming we could get an index store at all, then we know what the light index is. So this stuff like group light index just goes away because we're now using an allocator. We don't keep a running tally. That's gone. So now we go, all right, we're going to get the lighting index from whatever the chunk says it should be. We've got a light box here that we're going to pull out based on that, right? And that light box count, that gets written every frame. So this is not based on the chunk because it doesn't persist at all, right? This is new every frame, so that's fine. We go through here and just assign exactly what we expect to assign, so that's all good. And this all just works. Now, I suppose, actually, there we go. That's just that. So now when we do if light index store, this is really in the wrong place. So what we want to do here is say if we don't intersect, and this is light chunk store. Sorry, I just forgot the name change there. So when we come through here, if we have a light chunk store, then what we need to do is we need to write back to it in basically all cases. So what we want to do here is if we don't intersect, then we want to make sure we clear it. Right? So this needs to get freed. And so if we're going to clear it, what we need to do is in here, the light chunk store actually needs to get pushed onto the free list. So what we want to do is basically have a free light chunk function, really. That works like this. So we pass in the light chunk that we want to free, and it'll free it. And then we get this this place where whoever on the outside who was doing the lighting, the person who was storing where we were doing the lighting, that just gets overwritten, right? So I think that's all roughly what we want. Now, when we get in here and we do decide to participate in the lighting, then we're going to allocate. If we can't allocate, we don't need to do anything, because if we can't allocate, we don't need to push anything on the free list. We already don't have anything to work with. So we just wouldn't execute this loop. Assuming we do execute this loop, then we're all good. So in here, after we do our light index situation, we can grab this out here like so. So we don't have to worry about that anymore either, right? So I think that's it. I think that's it. So anyway, this will probably have to get cleaned up a bit, and there's more stuff that we're going to want to do here. But that pretty much tells us what we need to know. All right. Now on to phase 2. So that will allow us to free light chunks and reuse the free light chunks to allocate. What it won't let us do is let us know when an entity that was previously holding some light indices, for example, just doesn't need them anymore, because it's not on the screen or something, or it got deleted, right? If an entity got deleted, poof, then it's gone. So there's two ways we can address this problem. One is we can actually track when entities aren't being used anymore and say we want to free the lighting points. I don't like that solution because that solution is very error prone. If we ever get a case where we get rid of an entity and accidentally forget to free its light, we've got a light memory leak effectively, which will just build up over time and ruin the lighting solution. So what I'd rather do is have some way of just storing whether or not these light things were used. And I think the easiest way to do that, at first anyway, and we could compact this down. In fact, I'll put a little to-do on it here. Compact down to a bit array. What I want to do here is just say light point used. So here there would be a light point used array, that light point used array, and I guess this, call it like this. That light point used array is just going to say whether or not on any given frame the light points actually got used or didn't get used. So what we're going to do is when we actually begin rendering, this has to get cleared, right? And then every time we go to use one of these, when we actually use it, so in this case here where we're actually going to use whatever the light chunk is, we say so. So whatever the light chunk store says, whatever that thing that got written back in there is, that is going to get set in the light point used array and say, okay, this light point is going to get used now, so we set it equal to 1. Hopefully that makes some sense. All right. So what we want to do now is we want to actually implement the things that handle this stuff, right? So we've got two different functions we need to implement here. One of them is free light chunk. Free light chunk is going to take this game render command structure here, which stores all of the data, and it's going to take a light chunk index, and it's going to free it. The other kind we're going to do is a sort of like begin light or I don't really know what to call this, but we're going to call it once before we start every frame, which is a frame sweep here. This doesn't need to be inlined. Not that the compiler cares what I say there, but you know, just to be fair. This is a thing we're going to do every frame that sweeps over the light points used and sees whether any of them need to get freed. All right. So how this works is we'll just say exactly what you would think we would say. This is just a light chunk index here. Equals 0. Light chunk index is less than light data width divided by light points per chunk. That's how many chunks we would have. And this is a little misleading, so it's really going to be like, so for example, if we take a look at how much light data width is, it's 2 times 8192, I believe. Is that correct? Yeah, it's 2 times 8192. That's what we've got here. So that's how many light, things we have to allocate. So 2 times 8192, or can I just do answer divided by, yeah. So that total number of lights divided by 24 is not an even number, right? So that means we don't actually have all the light chunks that we might want. We actually hemorrhage a little at the end. That's okay. I'm fine with that. We don't really care about that at all. It does mean that probably light data width should be a multiple of this, or we should give out 32 per or something. But again, that's all stuff we can do for tuning later. It doesn't really matter. So when we do the light chunk frame sweep, we're going to go over each of the chunks that we have here. In each chunk, we're going to see if light chunk used. Is it did I actually call it light point used? I did. That's dumb. What I want to say is light chunk used. So if it's not used, or I guess what we should say, we could do it this way. If we see that the light chunk is used, we will set it to 0. If we see that it was not used, we free it. Make sense? That's it. So every frame we sweep over all of the light chunks. Any one that was not used, we free. Any one that was used, we clear to 0 so that we know that on the next frame it has to get used again in order for us to not free it when we come back around. In order to free a light chunk, pretty easy. It's just those light points there again. Light chunk index times light points per chunk. That's the point that we're gonna be addressing here. Again, we're just using that space effectively. This gives us a next free pointer. The next free pointer is just going to be the command's first free lighting chunk, and then the first free lighting chunk is going to be the light chunk index. So that's it. Right? Very, very, very basic, nothing to it. So all we really need to do now is every time we go to begin whatever rendering we're going to be doing in our platform layer, so for example, where we deal with this stuff, the default rendering commands, we are going to have to provide memory for it, so that's fine. That's really not a big deal. But more importantly, what we have to do is we have to sweep through and clear it every frame, right? That's the sort of more pressing issue here. So what we want to do is before we ever do any rendering, so before anyone could do any rendering at all, where we would sort of do those operations. You can see in here while global running or whatever, and we start to do stuff here. Just right at the head end, we should, I guess, let's see here, Xbox controllers, processing. I don't think we do any rendering of any kind here. So here we go with our back buffer, off-screen buffer nonsense here. I don't know why that's still there. Do we even use this anymore? Is this actually used? I don't know. Maybe it is. Anyway, so when we come through here and we start to do this stuff with the game update, what I'm going to do is I'm going to call that light chunk frame sweep. That's actually going to get performed on the render commands, like so. So this is something that has to live in code that can be accessible to the platform layer, and at least for now. And so that has to be, you know, maybe in handmade lighting.h is a fine place for it because it's an entirely lighting based thing, you know, or I don't know. It doesn't really matter where it is at the moment because only one person is really dealing with it. So there we go. So I think that would be fine. Very well. I guess commands isn't pulled out here. Render. What is this called? Game render commands? Yeah. So let's just go ahead and fix the compile errors. Lighting point does not have an operator arrow. That's a good point. It definitely doesn't. Light point used. This is light chunk used. Free light chunk. Conversion from U32. Oh, light chunk store is a U32 store? So it is. That is no longer used. Light point count. Oops. So I don't know how we want to deal with this particular issue. I guess we need some way of figuring out which of these light points is actually getting used, I suppose, in order for us to do some of the things in here. Let's just take a look here. Because that's really the last of the stuff, the issues that we would have. So if we take a look at where light point count is actually used in the solution, that's what I'd like to do, because I want to know everywhere we use it and see what we want to do about that. So if I go ahead in here and just get rid of the point count, I want to see what sorts of things we're using it for. So we loop over the points here rather than the boxes, right? And then we do it. I think that might change. Here we normalize them down. And here we sort of store their previous values into a separate buffer, right? So I'm not sure what the best way to handle this problem is. So I guess what I would say is, for something like output lighting textures, I mean, basically the problem we have is we've got lights scattered throughout this array, and there's holes in it where there's stuff that isn't actually used by anybody. And we need a way of making sure that we don't do a bunch of processing on stuff that doesn't exist. I'm not sure to what extent we want to go, though, because it's mostly going to be dense. Like, we're always, anytime we freeze something, we're going to use it on the next frame for any new people that come in. So it's not like we're going to leave huge holes lying around for very long. So I don't think we want to do too much work to deal with that. And so most of the time here, I think we're okay as far as just, you know, processing light points as an array. I'm just not sure. The only place I think we really have a problem is we don't ever want to spend time computing lighting at points that we don't actually need to compute it for because there's no box there. So for something like output lighting textures, I'd be fine with just sweeping over the entire array, not using the point count at all, right? Just using the entire data width, and that's fine. Because I think we have to keep that number relatively low anyway. And then, for example, in here, we don't really ever use I also don't know why get current quads. I'm not sure what get current quads is doing there, because we call push quad, which itself calls get current quads, doesn't it? So I don't even know why get current quads is being called there. That actually this routine is not dependent on the point count in reality, I don't think. Push quad. Oops. Push quad. Yeah. So that's only if you want actual access to that group, which we don't care about. Right? We're not setting anything on the entry there. So I'm not sure why we would really care about that. I mean, I guess it puts those all in a group. It makes sure there is a group. I suppose that's one thing. But again, you know, we know we're looping over this many things. And we know, you know, that's how many each one's going to output. So I don't really know that it's all that complicated anyway. I think that's basically it. So I really think it comes down to like, okay, so this routine, it doesn't really matter. This could loop over all of them, right? This could say loop over all the ones there are and just do them. And for those that are, you know, invalid values, it doesn't matter, right? It'll just process the invalid values and stick them into the data stream, but no one will ever process them, so it should be fine. So I'm pretty sure that's actually fine. And even if it wasn't, we could use the array that marks whether things are used or not as our guide. And maybe that's the right way to do it. Maybe the chunk index is the better way to do that. For example, I could do this. Right? So I could do something like this where we just say, all right, we've got the chunk count. Oops. So for each one of these, we're just going to do, you know, chunk index times light points per chunk. That's the one we'll start at. We'll go to the next one. And so in here, we'll just say if group commands light chunk used, chunk index, then push it down. So basically what happens here is we'll only update the lighting if we know that this thing was used, and off we go. So that gets us out of the business of ever checking that particular value anyway. And that leaves us with just that routine, I think. Right? So then most of what we have to worry about is sort of where we were doing this information that really should be ping-ponged anyway, where we have average direction to light and last direction that kind of just want to be swapped. You know what I'm saying? So you know, you really don't want to have to do those copies, but even if we were going to, right, we can just do the whole set for now. So we don't really have to modify that. We just copy more than we need to copy, and that's fine, because that's not a particularly slow part of the process yet. Signed, unsigned mismatch, you tell me. Is that so? Ooh, because this gets integral promoted. All right. So I think that's really all we need to do now to keep everything actually working on an allocation basis. So this to-do, this big to-do is now gone, right? We've got that taken care of. So looking a little further down the line now, if we want to actually get this running, and then we've got a ton of debugging work to do. Next weekend's going to be debug-tastic. Looking down the line a little bit here now, we say, okay, when we go into this, we're going to have to allocate first. So we're going to have, again, inside the platform layer here, where we've got this bit doing its thing. We've got our emit_c0 was the last thing we were doing before. We now need our light chunk used memory here. And that light chunk used is just that. So now we've got the light chunk used. That's going to be 0 when it passes in, which is exactly what we want. And that's going to be initialized properly. So really all we have now is the problem of this iteration over the point count here. And this iteration over the point count is, again, we could just do it chunk-wise and only use the ones that are actually active. In some situations, we don't care. We could just do them all. In other situations, we probably do care. So it's a little bit hard to say which one we want to do there. Yeah. And given the fact that 0.0 is never used here, we also have to make sure we can account by leaving the first chunk open. So when we take a look at what's happening inside lighting here, when we do light chunk frame sweep, we kind of have to say, note, chunk 0 is always skipped because the 0 light index value is reserved for people who don't use a light index. So in this case, we never want to actually consider somebody free who's in that first chunk. That chunk is just invalid. And we're only gonna, we're only gonna deal with chunks that come after it. So what you can see here is kind of what happens the first frame when we call light chunk frame sweep. It builds a free list that runs through the entire light chunk set. And unfortunately, it runs through it. It builds that free list backwards, which we probably, I don't know if we want to fix that by running through the list backwards on the frame sweep. Hard to say. But, you know, it's going to build the free list. Everything, all chunks besides chunk 0 will be on the free list. We could also assert in here that we never try to free chunk 0. And that every chunk we try to free is in bounds. So yeah, all of that seems fine. So when we loop over our emitters here, we could loop over them again per chunk instead of looping over them And the way we would do that is actually pretty straightforward. So if we were doing this loop here, I think all we really need to do is just say, start with emit index with the first valid point. And what we can do here is say, all right, if the emit index, divided by the light points per chunk, I don't know if this is actually the best way to do this, but if we were just looping over them kind of straightforwardly, what we could say is, look, if the light chunk used for this particular emitter is 0, then we just skip it, right? Otherwise, we come and we skip ahead. So we could do something like that. I'm not sure that's the sanest way to do it. I'm thinking that probably the sanest way to do it is the way we were doing it before, where we loop over, a chunk index. Oops. And then we loop over emitters inside there. So basically this is just an if that wraps this guy. And this is a if light chunk used, chunk index, then we go ahead, otherwise we just don't. This is going to be chunk index times light points per chunk. So that's that. So this would loop us over the chunk, chunk by chunk. And I think that's really all there is to it. This same loop has to get done in multiple places. So here, for example, this loop has to occur for the point indices as well. So point index, point index, point index. There's all of our stuff for that. Seems like we're missing. No, this is correct. That's inside the iteration. Right? Yeah. So I think that's correct. So this, though, is not. All right. So this is going to do per chunk the old stuff that we were doing to update the dest emission, and we're going to have the array count every time through the iteration, but then we go back up and do another iteration. Again, everything based on chunks. Finally, we get to the end. This also has to be done on chunks. So there we go. And I think that's all there is to it. Now, we don't actually save this light chunk used into the lighting solution, so I'm going to have to put that in here. So this is just a copy out of the pointer. So light chunk used. When we go through and we start the lighting, when we, and here are in our lighting test, we can do solution light chunk used equals commands light chunk used, and that's, oops, really all there is to it. All right, so this is going to be an epic disaster because we just added a ton of stuff in here, and so we're going to have a lot of debugging to do. This is going to be, this is going to be rough. But let's at least run it and see what we get, and off we go. So it looks like we're getting an assertion here in our free light chunk call, and it looks like that is because. So we wouldn't actually be freeing this light chunk if, okay, I see what's going on there. That's the case of, if we go to free the light chunk, we have to make sure that there actually was one to free. So in this case, we've got, one that didn't intersect the lighting bounds, so we can get rid of it. What I just realized, though, is we don't actually have to do that right away. We can just wait till the next frame to free that guy. So I'm not sure if we actually need to do that or not, because the light chunk used part of things will automatically have that happen. So what we could do if we wanted to is we could just nuke that here. And there's going to be one more thing that's a little nasty here that also probably has to happen, actually. Which is when somebody comes back into the used set, we have to sort of do a check against their entity ID. So again, it's a little more, it's definitely a little bit more nasty. And this is, again, just to try to make it so that we don't have the issue of trying to figure out when people stop using a particular light. Which is to say that if you imagine how this is working right now, when we go through here and we look at what comes in the light store, we just assume that if someone says they had a particular light chunk, that they have it. But that may not be true, because we may have jettisoned it, right? And so if we jettisoned it because it wasn't used, then we don't have any way of confirming, confirming who actually used it. So if you take a look in like the entity stuff, where we've got this entity ID here, which is like a value that says which entity is doing something, right? That entity ID is something we would need to check to make sure that we always have the same person occupying a particular light chunk. Yeah. And so the only thing that's nasty about that is just the amount of data that's processed per frame to validate that information is pretty significant, right? So, like, for example, it's not that hard for us to make that work. When we pass in the light chunk storage value here, it's not that difficult for us to make that work. We can just say, you also pass in your entity ID or whatever, right? And we'll track that, or your unique ID, whatever it is that actually has to be ratified there. It's not that bad. The problem is the processing of that array just becomes more expensive all the time. It's 4 times more expensive now to process it because it's got 4 times more data in it. Because it has to store entity IDs instead of just storing a used field that's 0 or 1, which could have been compressed all the way down to a bit, in fact. So it's actually 32 times slower to process, in a sense. And that's not great. So, yeah, I'm trying to think if there is some way that we could... I really just don't see it, though. I don't see a way of making this... So the only other way I can think of that this would work, and it seems like this is just a bad idea, so I don't think I would want to do it, is that entities just store their previous lighting information directly inside their storage. And then when they pass in PushCube, they just pass what their old lighting was, right? So the reason that I don't like that is because entities never know when they could get rid of that information. So when they get packed back into a particular when they get packed back into their storage for a given region, they're storing all that data and that will never get freed. So your entities are always that big. They have all the lighting information still stored in them. Now maybe that's fine. And the reason maybe that's fine is maybe what you do is you then say you keep a hot list. Oh, well, yeah, this is actually way better, isn't it? So I guess then what you do is you say, okay, we just keep a list of all the people who went into storage last frame. Not people, but regions. And if those regions aren't loaded this frame, then we go through and repack them without that data. So actually, that's probably just way better because it's the exact same bookkeeping, meaning you just have to check, but now you don't have a free list or any of this other stuff. That seems strictly better to me in all possible ways. I think that's just smarter. I think that's just entirely smarter. I think that is really what we should be doing. So essentially what you could say is, okay, if the lighting is not enabled, we don't use this light store, that's fine. But now what we're doing instead is the light chunks are actually these things. This is way better. I think this is way better. So I think what we do here is we say something like this. How many lights do you want, and where do you want them? And then I think we just go from there, right? Those get packed in to the lighting array, and as long as you don't overflow the lighting array, you're fine. They get packed in and then they get packed out. I think that's just better. It costs some to do the pack in and the pack out, but the amount you save in bookkeeping seems well worth it because there's so much finickiness here that has to get done to track all that stuff. It seems that if you just got rid of it, it might actually even be faster because you are doing a rote process every time that's just not, it just seems strictly better to do that. Let me take a quick look here. So the light box itself, this thing, I say? So the only thing I'm not sure about is exactly what I want to store there. I'm quite certain that I want to do this into the entities now. So I'm pretty sure that this is going to be the right thing in the long run. So in here, we just need to store the lighting points for this entity, right? And the tough thing is we don't know how many there are, right? So we're not sure how many of these things we actually would store, but that's okay because our entity struct, when we go to do the game code, is flexible anyway. The whole goal of the system is that these things get packed in some kind of a streaming sense and then unpacked. So that's actually going to be fine. We have to deal with that stuff anyway, and it'll be okay. So most of the problem here, and we can just assume that this is how it works at the moment, most of the problem here is just going to be that I don't know what we want to do about making these things flexible from the standpoint of lighting that wants to have more information to it. So in the case where you want to smooth lighting between two different things, or some of the more complex lighting stuff that we might want to do, I'm not sure exactly how that stuff will get handled. Since entities are sort of separated, that's going to be tricky. That's going to be really tricky, and I'm not sure how we're going to handle it. Yeah. So just to be a little clearer on how this stuff goes down, so if we have lighting points, like just as an example, where is my Milton? There it is. So this is the part that I'm just not sure about. And to be fair, this has nothing to do with what we're talking about right now. It's just a thing that like would have come up one way or another. But let's suppose that we have some walls that go like this. And furthermore, I guess we can make a more complicated scenario just to illustrate the full problem that we're going to have. So let's suppose we have a wall section that looks like this. And we make it up out of a couple different entities. You know, here's entity 1, here's entity 2, here's entity 3. Now, ideally, what we would like to do for lighting is maybe place a light sample point here, here, you know, here, here, maybe some here, 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 there. Something like that, you know? So we'd like to kind of scatter those lighting points along the surface. And then what we'd like to do is we'd like to sample those lighting points to reproduce the rendering as we go across these quads. So this quad here, you kind of want to sample all of these. This quad here, I'd want to sample like all of those, you know. And the problem is we have lighting points here sampled per entity that want to be shared. Right? So you want to have a light sample point that gets used for interpolating two different entities' quads, and the reason that you want to do that is because you want the lighting to line up very closely along those seams, you know? And so the problem that I foresee is I don't understand how I'm going to get that behavior to occur in this system. I just don't know how I would articulate. The renderer could handle it just fine. I just don't know how to tell the renderer to do it, because I have no idea how I would ever take two entities which are stored completely separately and have completely different data. I don't know how I would tell it, oh, hey, these two entities share this lighting point that I need you to use. Like, how would we ever do that? It seems like totally impossible, right? And you know, the sorts of things I can think of that would allow us to do that are just really like fanciful. They're like, oh, I'd have to have every lighting point is actually sort of its own, you know, they aren't entities per se, but they're sort of their own identified units. They're their own identified elements, you know. And those elements are actually like, well, okay, all right, okay. I mean, maybe I can sort of see one way you could do this. So maybe one way you could do this is by putting lighting into blocks that are large. So basically I would say, all right, you know, let's say I've got a screen I'm looking down on, and you know, it's like a dungeon screen, so it looks like this or something. Here's the walls, right? And so I've got all these lighting sample points strewn all over the thing like this. Right? I suppose what I could do here is say, all right, suppose I broke lighting into chunks where the chunks actually are arbitrary sized chunks and are entities. So lighting is stored as an entity, any number that you want, that you put back into, you know, a region, and that lighting entity gets pulled out. Or maybe they're not stored in the chunks, maybe they're stored separately. But the point is, they do have a unique reference ID. And so there's a certain number of lighting point distributions, and you pull one out, right? So I would say, okay, this lighting set of points is, you know, this is point, oops. This is point set X, where X is some, you know, unique ID. So when point set X gets pulled out, any entity can refer to this point set, right? And so when you go to push an entity on, you do actually do like a hash table resolve for whether that point set has been pulled out yet, and if it hasn't, you pull it out and you block it into somewhere in the region. So you effectively say, okay, yeah, we've got a point set. That point set gets pulled out of the of sort of the set of lighting points that are in flight, and you can refer to anybody in it as part of your lighting solution. I mean, I'm okay with that. That seems fine to me. And then we just don't have that problem anymore. Because now you really can say, hey, this is the lights that I use, and if those lights are still around, great. If they're not still around, then you just have to recreate them. And so that would probably just work. Yeah. I mean, I think that's fine. That's probably fine. Yeah, I mean, I think that that's okay. And that allows entities to share information about lighting in some predefined way as necessary, which we kind of need to do for like continuous wall segments and stuff like that, I think. I mean, the only other option I can think of is that when lighting points get added to the system, they get merged if they're the same. That's another option we could do. So that would be, you just have entities specify the light points. Each entity specifies the light points that it actually wants. When these light points come into existence, they get merged based on their location in some kind of a spatial merge. To be honest, I'm not really sure which of those is going to be better in the long run. It's pretty tricky. I guess what I would say is that it does seem a little bit like this way is too static. So if you were to use point sets in this way, while it does sound kind of elegant at first, what I'm thinking about is assuming you want things like destructible walls or things like this, which we might want in this game, you end up having a lot of problems because you're going to have to update these point sets, and you end up in a situation where entities can't really be treated individually anymore because they've got this sort of information binding. We've kind of tried to stay away from that so that everything is kind of this flexible, independent element. So I guess what I would say is maybe that's a good argument against the point sets. And maybe what we have to do is we have to do something where we can just say, all right, light points get merged when they come in if we want that to happen. It's a post pass that happens, and you're just going to have to make that work because we don't want to have to specify this stuff ahead of time. You know what I'm saying? So if that were the case, then yeah, it looks more like this, where we've got these lighting points here, where we would just say, okay, entities have their lighting points. When you come in and you want to push one of them on, you push on, whatever the lighting points are that you want to push, and that's where they go, right? That's just where that information goes. So then when you come through here, you don't have any free lists or anything like that. It's simply not something that's ever managed. Instead, what you do is you say, well, if these things intersect, then what we're going to do in this case is we're going to say that we just push on, like, I guess just a pointer to that information. Like, we just point to it, really. Is maybe it's hard to say. I mean, let's do it the most straightforward way first, I guess, which is just record these things individually. So instead of the light chunk used, and what the heck was that? I have no idea what's going on here. My graphics card seems to be freaking out. So what I want to do is I want to say that the command structure, right, what that's going to store is individual light chunk information. So along with the light boxes, and I guess this could just be stored with each box because that's just kind of how it goes. I guess this lighting point array thing just would not be stored at all anymore. They would just get pulled out as part of the lighting solution, right? So the emit C0 and the light points, I think that stuff just goes away. I'm not really sure why the emit C0 is there in the first place. Let me really quick see where that's coming from. Because I think that's not necessary. That was just getting stored sort of as a long haul thing. Yeah. So I'm pretty sure that would just get rolled in there. No, that's not true. It does get stored per light point here. So that is kind of a light box attribute. Yeah. So I guess what I would say there is, inside the lighting box, maybe then what we would say is that the emission value goes in there, perhaps, would probably be more what I would want. And I don't know how we want to store the emission value. Maybe we want it to be per face. Because right now we're over specifying it, right? We specify the emit C0, but we don't really need to because the emit C0 is not actually necessary to be stored here because especially at the moment, we can only say that a cube comes down and the whole thing is lit. It has an emission value. Now, in the future, I could see us wanting to do something where cubes only like had one face lit, maybe. At the moment, we don't, though. So, maybe there's top emit and, like, side emit or something. I don't know, something like that. We could do in the future, but at the moment, I think what I'm going to do is just put an emit there, maybe. And so, yeah, if we just store an emit value here, maybe we just pack that in, and that gets stored along with the light box, for example. I mean, the other thing we could do is just leave this pad, since we don't really care at the moment, I suppose, exactly how we're doing this. Maybe there's an emission value here, and that's just the emission value for the whole cube. So rather than storing emit C0, which I don't really think we need to store in here at all, we could get rid of all of this stuff. It's just gone, right? And we don't store any of these pieces of information. Did I delete something I shouldn't have there? No, I didn't. So light points are gone, light chunk used is gone, all of that's gone. We just store the boxes, and the boxes store the emission in them. And then the points will get generated later on by the box information, let's say. So maybe like we will have something that lets it know how it wants to do that or something like this, but at the moment anyway, we're just going to pass that information down directly. So that seems pretty reasonable to me. And then this surface index stuff that unpacks, that'll go somewhere else. So inside the lighting box now, what we want to do is we want to say, okay, the lighting box that we generate here, this thing has a pointer in it for the storage. And so when we do light points, they get stored back into there. And that's what we'd actually be providing here, is the place where we write back or read from that piece of information when we want to actually use this thing. I think that makes more sense. And so I'm going to go ahead and do that. What did I call this thing? Light store. So that I really like a lot better. And the reason that I like that a lot better is because now the decision to persist lighting information for smoothing purposes, which is the whole reason we needed that in the first place, is just something that can be handed off to the entity system, which is already doing stuff like that. So we don't have a separate system inside lighting for storing information. The entity system will just record lighting information as it sees fit, and when it decides that it doesn't need to keep lighting information for anymore, it just throws it out. And that seems a lot nicer to me, because then we don't have this situation where, you've got sort of two redundant systems operating in parallel and having this kind of nasty bookkeeping going on between them and all sorts of other crap like that I don't really like the sound of. You know what I'm saying? All right. Oops. So if I come through here and need to kind of clean up how this stuff is working. I don't know what that was supposed to say. Note, 148 million. Okay. That's a great note, Casey. Thanks for keeping that in there. So what I want to do here is I can restore a point count now, and things could work based on point count, and we'll see how that'll go in a second, I think. So that should be pretty good as well. So yeah, I think we should be able to now make this work in a more sane fashion than we were doing before. When we push these quads on here, we still have the issue of we do have to know where the light indices line up in terms of what we're actually sending down to the graphics card. So in this case, we actually do need that light index to make some sense, right? But this becomes a little bit more straightforward as we go. We should be able to now just say, go back to the way we were doing it before, where light index just equals group light index, and the group light index plus equals light points per chunk, like so. So that method of operation can be restored now. They just stream out, and they are unique per frame. So these light indices never get persisted. Nobody stores them anywhere. No one does anything with them. We can then also say this light count here. I guess this also could come in here. This all looks right. So now we've got this light index here and the light push truck. All this stuff looks like it's operating how it should. When we come through here, this just needs to know where the light index started that's copying out, and you know it did exactly that. So it keeps all of track of that information exactly as it used to. It's storing where it's going to write these back when it eventually needs to do so. And then this piece of code here that was generating the points on the surface, that can actually be moved now out to the lighting solution proper, I believe. So inside Handmade Lighting, when it goes to do the actual lighting test and do this nonsense here, before it does anything that actually does the light propagation, it can do this piece of work here. So we can do this, I'll just bracket it so we can see that it's a little to do here. And so then what I can do is say, okay, when I go to push one of these things on, I just push the light box on. I don't push anything else. That'll get processed here later on, which is what I want. I come through here and I store all the information about how this light is supposed to work. And then the light index and the light count should be set properly on the way out of here to correspond these to where I said they were going to be inside my lighting solution, right? So I've got two things here. I've got the storage that comes in, and that's this piece of information here. And then I've got the light indices inside the lighting system. And what I can do is copy in and copy out that information to produce what I wanted to produce, right? Okay. So let's talk about how that's going to work on the back end, now that that would be how this would work here. What I want to do now is I do need a scratch array for this stuff for my points. So this is going to become an actual array now, and it will have an actual point count because that's going to be how many of those things we actually pushed in there. So that's a real value now that actually has meaning. Emit C0 and emit C1 are actually going to be stored now too, so all of this information is going to be sort of kept in there. Last emit and last direction are the pieces of information we would actually need to store in the light storage. And I guess now that I think about it, I suppose those have to be kept in here then, because this is the piece of information that we're actually keeping, right? So when we copy these out, we need some place to put them. So the lighting points themselves is, I guess, you know, I don't know how exactly we want to think about this, but the lighting information that we have to pass into that routine has to be able to be unpacked into this. So the lighting point, I guess, is the wrong thing to store. What we need there is actually the lighting memory. It's like a thing that we remember. Lighting state. And what that's going to have is the emit and the direction. So really, this is not a lighting point. It's a lighting point state. I don't know what that is still doing there. I guess we previously were type defing these. Maybe we should again. I don't know. We'll deal with that later when someone complains. So anyway, inside here, what we want to do is we want to say the lighting point state is the thing that we're keeping. So that lighting points themselves are just created as an artifact of this particular routine. The lighting point information is what gets copied in. And then the rest of this stuff gets copied back out to there, right? I think that's all we really needed. So at the beginning, what we would do is when we come through here and expand these points, we would copy the information there at that point. You can see here we save the average direction to light, and then we zero the one that we're actually using. So in this case, we would be just zeroing the one that we're actually using. This copy would now happen after this, so that would happen here, where the average direction to light gets copied out along with the emission. These copies will actually be per element now, out to the lighting boxes, and these are per lighting box as well. So I think that should be fine. I don't think we need to keep last direction or last emit because I think those can actually just be warm loaded in the place wherever they actually need to be. So I think these can go away. And last is valid can also go away. Last is valid is actually a bit tricky now. So the only complication I see here is we will actually have to do last is valid as something that happens per lighting point, per lighting box. So when we push this data in there, we have to know, did we actually have stuff in there that's actually workable? Or is it just garbage? And it needs to get erased, right? And it needs to get overwritten with whatever you solve on this particular frame. Does that make sense? So I definitely want to do that per box because that's going to have to occur now. All right, so now we're actually not too bad off. What we're going to do here is we're going to loop through each of these, and I can actually restore the concept of the point count now. And this can be made more straightforward. So we have a point count and points. All of this stuff can be done as it was being done before. So what I'm going to do here is I'm just going to loop through the boxes. Box count. That we got as input. Now, I want to do this before we build the spatial partition, because the spatial partition is going to add boxes, and I don't want to process any boxes that I don't have to. So I know that all the ones that are coming in here are real boxes, for lack of a better term, and so I want to restrict myself to only dealing with those. You know what I'm saying? So for each one of these, now I could loop through my point indices. So I want to loop through point index, whatever the box light index 0 is. I want to go through the light index 6, I believe, which is the last one here. And then I plus point index. So now I'm going to go through, and each point index that I have, I'm going to pull it out of the storage, right? Now, I could just use a memcopy here, which might be better. I don't know, we can look at stuff like that later. I think the compiler should be good enough. Oh, well, no, you know what? I can't do that because I got to do this, right? So I have to actually make these things work properly. So no, that's not true, right? So I need to do something. I need to do something more like this, right? Where I go through surfaces 0 through 5. I actually get these out. I build the lighting points from them, and I should be able to do that by actually just looking at whichever light index we're actually talking about here, right? Now we know these light indices are contiguous, so what I should be able to do is say light index equals solution or box light index 0. Start with that and push all of these in here. Now, if storage was valid, then I could just copy them out. If it wasn't, I can't. What I could do is I can make, I can basically make concessions to that later on as we go. We'll deal with that a little bit later. So what you can see here is when we're initializing emit C0, that's a piece of information, again, that's going to be right here now. It's going to be in the solution. So when we're going to initialize emit C0 directly now. Not as an adjunct of the command state. And this should basically be just whatever the box said its emission was. I believe we properly stored that. No, we didn't. So we want to make this actually be, well, okay. You know what, I'm not sure how we want to store that information. So when we're sending emission down here, I don't know if we're sending it down, how we want to send it down. If we want to send it down 0 to 1, which seems logical to me. In fact, I'll put an assertion in here. Then we can multiply it out in here, and that'll be fine. This is just the box's emission value. Right? And so all of them inherit that same value. So this will initialize all of the lighting points in question, right? And then when we're done here, we can say if solution light point count, as we were before, or point count is less than light index, solution point count equals light index, like so. Although we should actually know what that should actually be known. So to be honest, I think we don't even want to do that. That's just a waste of ifs for no reason. I think what we really want to do is say solution point count equals group commands light point count, because they get serialized now, so there's no need to do a bounds check. So that should just be tracked the entire way through. Okay, so this will distribute all of our points as we want them distributed. We can then do everything as we were before. The copy out we can do in a separate place, and we'll talk about that in a second. We've got stuff we might want to do there. But in here, when we zero the average direction to light, just to clear out that array, that can still happen the way we wanted to, because that's just a scratch area. Emit C0, I think does C1, we never cleared C1. I assume that's because we clear it up here, right? Yeah. So that just kind of gets dealt with down here. What I would like to do is we can get rid of this stuff now, right? The emitter index can go back to being what it was before. Okay. So this can just behave the way that it was behaving. Again, same thing with this. So we don't have to do all that nonsense that I was doing before, which I was not liking. And now, what we can see here is when this produces the new lighting solution, what we want to do is in here, this last pass, you can see that it's operating kind of over the, it was going to operate over the points before. And we want it to be able to use this last, the sort of the last emission, last direction information. What we want to do here is we want to stop doing it that way. This is the part now where we want to loop over the boxes again and actually grab the previous results to the extent that we have them, right? And furthermore, in here, we can make this be, we could actually pull this out. So when we do compute lighting solution, this part here, this finalization, we could actually pull this out if we wanted to and say that that's actually part of this. So we can see it a little more cleanly here, the two stages of the copy out and the copy back. So you can see here where we do this copy and storing that information. We're not going to do that anymore here. Instead, what we're going to do is we're going to mimic what we did at the outset, where we actually go through the lights that are involved per box, and for each of those we'll grab the previous information and blend it. After we're done blending it, we'll write it back. So basically we're going to pull it out, blend, write back. Now we may want to in the future pull out the emission information, so instead of blending the way that we're blending here, we may want to blend in a different way. I know this sounds a little confusing, but basically what we're doing right now is we're redoing the lighting calculation every frame, which means that any light propagated on a previous frame is not repropagated on a subsequent frame. So the light restarts, the lighting solution restarts every frame, and the extent to which we use the previous frame's information is just as a blend to try to sort of keep the light from changing too much per frame. That's probably dumb. We can probably do much better than that by saying, let's just track the propagation frame by frame and keep what we did on the previous frame alive for the next frame so that the propagation just gets better and better. So we can probably do stuff that's smarter there. And I'll put a note about that, but at the moment we don't want to go down that path because we're just trying to sort of clean up how we're actually doing this and debug it without that extra sort of complexity introduced. So that's just one thing that we should look into in the future, and that again is just about getting a better lighting solution for the same amount of computation time, because one of the things that's true in something like lighting where you're trying to get a particular result that you know you can never achieve, which is like the perfect propagation of light of what would really happen in the real world with these lights or something, right? And you're never going to get that. The amount of computation necessary to produce that it's hours of computation potentially, right? depending on the situation. I mean, maybe not anymore because computers are much faster these days, but it's, minutes of computation, let's say, even on a very fast machine for certain scenes. And so we know we're never going to get that. So what we're trying to do is figure out, well, okay, we've got a certain budget. We've got a certain amount of computation we can spend. What's the way to make sure that we're spending that computation time to get the best result we can? Because we certainly don't want to sit around doing a bunch of computations and then throwing away parts of the information we have revealed that we could have used to produce a better lighting solution. So you want to make every flop count. And that's something that we can look into kind of later as we go. How do we make sure that for the computations that we do have time to do, are we doing them as efficiently as possible, or are we getting as much information as them as we can? Right? So the smoothing is one way to just simply make the lighting look better by reducing the flicker, but it's possible that we could get a lot more mileage out of that storage by actually using it to help guide our solution every frame. And so that's something that we want to kind of develop going forwards. And again, that's not going to speed us up, but it's going to get us a better solution for the same amount of speed. And that's important as well, right? Okay. So what we want to do here is take a look at the box value here. And this is, that box is valid, where did I put that? Lighting box, right there. So if the storage contents are not valid, what we want to do here is point to alternate storage. So what I'm going to do is I'm going to say, okay, let's say we've got lighting point state here, right? That's my storage. And we sort of have two cases. In fact, I guess I can just handle the two cases. If the storage contents are valid, we do one thing. Otherwise, we do another thing. So the point state here, in fact, I guess I don't need to do this. If the storage contents are valid, then we're going to do exactly what we were going to do before, right? Everything is exactly the way it was. So I'm going to start with the box's light index 0. I'm going to go until the box's light index 7 or 6, right? And I'm going to go through each of those in series. For each of those that we're going to do, we know what the point index is. I guess you know what I should do? I should do it this way. Right? So I'm going to go through each of the points, and then I know that we can look at whatever's in our solution, which are these things here. I know that I can look at those using that point index directly. Using an offset of that index. So I can say, all right, my point index here is going to be the local index plus whatever the initial box index offset was, right? So that's my point index. And then I know I can look in the box's storage to get what it was. So here where I come through, I say, all right, the emit C0 value of this thing. Wait, could I even do this the same way I was doing it before? I guess I could, couldn't I? Only if I actually make these be parallel, but I could. So in other words, if we said something like this is a pointer to one of these and it stores that, right? Then I could do it because now I've got an array of emitters, array of directions. I could also do it by saying that the emissions and the directions are interleaved, and then I could also just do it directly. So for example, if I was to say that lighting point state, which has the emission and the direction in here, that those were actually just stored as part of the point state. So for example, I said this, right? Then I could do that as well. seems plausible to me. Especially because you could imagine packing this thing down in a pretty concise way, potentially too. So yeah, maybe I'll do it that way. Let me just see what emit C1 is doing here, just in case there's anything weird, because we're not ping-ponging it, right? No, we are. So you can see here we've got like a source emit C and a dest emit C. Oh, although it doesn't actually ever ping-pong them. So I guess technically, yeah, if we wanted to, I'm just not sure if I want to give up that sort of cleanliness of having those be the direct packed arrays. Because we could ping pong them in the future. I don't know if we're going to. There was no reason to do so here because we had to renormalize the samples. But if you look at what's happening here, this sort of copy and clear, you could imagine this being done a lot more efficiently, right? So yeah, it's a little dicey. It's a little dicey. So I'm gonna go ahead and stick with what I had before. I don't really want to go down that route yet, because I'm just not sure about it and it seems a little bit iffy to me. So I'm gonna just say we don't do that yet, and we'll cross that bridge when we come to it. So if I'm here and I'm looking at my box index, situation, I'm just going to do these separately. I'm not going to try to do anything fancy. So if the storage contents aren't valid, then there's really not much that we actually have to do here. We just write back the values, and that's it. Go ahead and clear that out. If the storage contents aren't valid, then we need to average them. So let's take the easier case first. When the storage contents are not valid, then we don't need this lerp here, and we can just say that whatever the solution says that it is what the solution says is what it is, right? So if we take a look at this here, we know that our emit C0 is just going to be whatever it is, so we don't need to touch it at all, right? So we know we're going to write back something here, and then our average direction to light is going to get normalized, which is this. So we do actually need to figure that part out. So we'll get the direction here. Here's the emit. Here's the direction. And so what we want to do is we need to write back, we don't need to write back the emission, we do need to write back the direction because we are normalizing it. And then what we want to do is we want to take wherever these were stored in the box itself, and we need to write those back. So inside the box, we know we've got this right here. So the storage for the emission is going to be the emission, the storage for the direction is going to be the direction. And I suppose we can make this a little bit more cheeky if we wanted to by saying, well, okay, so since this only gets used in one place, we can just do it like that. And if we just abuse having the equal signs line up, we can also do this like this. So here we say in the case where the storage contents are not valid, we basically make them valid like so by saying, into that storage, we're going to write back whatever the emission was that we computed, and into the directional part, we're going to write back the normalized version, which we will also write back into the actual array that we use, that we send down to the game, right, to the GPU. This doesn't have to be done this way anymore. So in this case, we can go back to what we were doing before, exactly as we were doing it before. This one, again, has always worked this way and can continue to work this way, so that's totally fine. It can go back to doing this if it wants to. So in here, really, this is all we need to finish now. This particular piece of information this particular operation still has to occur up here, just in a slightly different way. I think all that looks right. So when I come through here, what I want to do is do this blend, exactly the same thing we're doing here. I want to do the double store. So basically what I want to do is say, okay, I'm going to go ahead and store whatever the last thing was. The last thing here is going to have to be pulled out as well. So here's that emission value right there. Here's the new one. So the old one will lerp to the new one at this rate, and we'll store them both back into the things that we actually process. Same is true for the last direction. So this part right here, where we're storing back the last direction, that comes in here. We don't need to normalize it because we know it's already normalized, since it had to get stored in the last frame as a normalized value. So we're just doing the lerp here. Again, reading out those values from the storage and then going from there. So I think that's everything that actually needs to happen here. I don't think anything else needs to occur. This light index value for box, this is not used anymore, so that's just gone. So now we have some cleanup to do, right? We've got to figure out how we want this stuff to work. This is actually lighting storage here. Let's do something like this. What? Unknown override specifier. I'm assuming that's because lighting storage is not defined. Light point state. That's what I meant. But I guess this is not defined yet. It should have been, because the lighting information should have been specified. Let me just take a look. Entity is here, lighting.cpp is here. There's our problem. Inside our lighting solution, v3 needs a semicolon. So this needs to get implemented, and that's fine. We'll do that in a second. Storage equals light store. There we go. And so now we're down mostly to it. So in here, we don't need points, we don't need emit, we don't need chunk used, all that stuff goes away, and we do need to, however, in our pushing these things on, we do need to clear it for the commands. So I don't know. Since these have to be unique across the entire time we use them, I think technically it's got to be in here. So I think technically this has to be in here. And so this is actually... right? And so that is something that actually does have to get cleared down at the bottom, right? So when we do this, we have to do light point index equals 0. Although actually, I suppose since 0 is never used, technically what we need to do is do this plus equals beforehand. So, you know, this actually has to be like this. Although we only want to skip one of them. So it's this, right? When we start doing our rendering here, this thing wants to be, when it gets initialized, right? This thing wants to do that. So in here, when we're doing push cube now, we actually have to do something a little bit fancier than that. And we've got a bunch of stuff we're going to have to deal with. So let's go ahead and make that happen. This is actually a light point index, not light point count. We got light points in here. That is not true. So those should be actually stored, and they are, so that's good. This is just box. Right. This is just points. Color.rgb. So that needs to get specified as part of the box as well, doesn't it? Because inside here we don't actually store that piece of information. So I guess that is one downside of not storing the lights separately here. This really doesn't have to look like it does at the moment either. There's probably a lot of stuff we could simplify here. Because right now we're also being a little bit aggressive in terms of what we actually, you know, remember. But here's the refc. And so what I could do is when we push that on there, we could store that information. So when we do our emission value, and then in here, you know, we just track that information. So that I think is mostly okay. Now we just have to kind of deal with some of the fallout here. That's going to be assigned unsigned mismatch, which is fine. Let me just promote these to U32s before the subtraction. Let's take a look at what's going on here. The storage, I think it's called direction. Actually, I don't know why I typed dir. Let's expand that out. And that's about it. Really, now we just have to make sure that when we actually push these things on, they're pushed on in a sane way, right? All right. So now when we do push cube, this has to be a light point state. And unfortunately for us, this is a little bit dicey. It's kind of hard to know what's going on here per se. We will, I'm sure, do some various nonsenses. Where is the visible piece? Here we go. This is just completely piggy. Actually, you know what? I'm not going to put it there. Put it out here. I'll leave it where it was. So when we have these pieces here, So what I want to do here is say, well, all right, this, we'll put the lighting in here for now, but eventually we're going to do this in a very different way, so I'm not going to think too hard about it at the moment. What I'll do is say, instead of addressing off the piece here, I'm going to use the actual piece index and use the lighting information. Like so. So that will actually... It's not what I wanted. I just wanted lighting. So I think that's what we need now. So we'll do push light there. Same thing here. Bitmaps don't get one. And then inside push cube, clean that up. Here we go. And we know that this thing has to be that wide. So again, a little, this is a bit loose there, obviously, because we're kind of fussing with it a little bit. What we don't have right now is a good way of knowing whether or not this thing was accurate before. What I realized is actually we have that information, so I'm kind of dumb for thinking I needed to store that. So if we take a look at what happens inside the lighting box, we don't really need storage contents are valid. Like, that's just not necessary at all. Storage contents are valid is a waste of time because we don't need to look at storage contents are valid. Instead, we can just look to see whether or not the normal of the first point is a valid normal or not, right? So if we wanted to, we could just say, okay, we've got a lighting point here. So where's the storage? So this storage value here, let's just take a look at lighting point state. That's the first point, right? That's what that's going to be. What we can do here is just check if the direction of any of these is non-zero, then it's valid. Because it's a direction. It can't be equal to 0, 0, 0. Although the reflected one could be, if we had 0, 0, 0 here before, then there wasn't any information here, right? We never collected even a single sample the previous frame. So it definitely never got a valid lighting solution, and whatever you got this frame, we should probably use, right? This is not what I wanted. I actually wanted that. So I think that correctly does everything. Now we're massively over time now, and this isn't going to work because I made so many changes. It's nuts. But you get the idea. So I'm going to leave this. I guess I could just debug the basic crashing stuff, but yeah, I'll do a quick little check. Is this correct? No. Here we go. Box. Okay. Box. So the storage got set to something, but that something is not legal, which is a bit weird. So let's find out why. The light boxes all come from the solution here, right? It says there's 67 of these. Presumably they all got pushed on. Let's go take a look really quickly here of where they actually get pushed. So in here, when I push one on, presumably the storage always gets set, and so this should be a valid value, right? Because in order to actually get one pushed on here, you have to actually have reasonable data. Also. So I'm not sure exactly why that would be causing a problem, but we certainly could try to make it fail earlier and give us a hint of what was going on by saying, well, if the storage value is wrong, then what I could do is just reach into it here, right? Say, okay, whatever the light store is, let's just set the direction equal to some value, right? And so that should crash like right away on push if it was actually a problem of storing the boxes. But it looks like it's not, because it's trying to access this first point here that appears to be the problem. So I feel like the box itself that are getting pulled out is the issue there, and not the ones that are getting pushed on. So let me go in here and just see what's going on there, if there's something strange that I don't understand. Yeah. And in fact, you know what else I can do? Let me step into this routine and just quickly take a look at what that box array looks like when it actually comes in. So if I set a breakpoint here on lighting test, here's my box count at 67. Let's take a look at what the boxes actually are. And even the first one storage is garbage, right? So something bizarre is happening here. Is it just like that the first one gets overwritten, or are they all garbage? So they're all garbage. Oh. That's actually to be expected. So in order for them not to be garbage, the lighting solution has to be run prior to throwing away the simulation state, because we're going to write the entities back in. So we actually need this to run, the lighting test to run. That actually needs to run inline. So this right here actually has to be done like this, because we want to capture the information that it's given. So that might be part of it. Yeah, and that looks a lot better. It looks like the last box is invalid, however. Oh, wait, no, this says there's 106 now. This is how many boxes there were last time. It thinks there's 106 boxes this time. So that's a little bit weird. Let me go back to testing what I was testing before. Because by the time I get in here, I mean, light store has to be set to something or I couldn't have gotten here, right? So I'm not sure how I would get the light box count to do what it just did. Now, I guess I should double check inside the render group here, inside the Handmade, to make sure that I'm resetting that value correctly every frame. But I am. So the only question would be if it gets, like, fussed with in some way that it shouldn't be fussed with. Yeah, that's peculiar. So if we take a look at what happens when I step in here, the first time through we should have 67. And all 67 of them are fine, or they're not? Ah, that's why. Because we're looking through boxes that have been added as part of the spatial partition. So on the way out, we strictly want to confine ourselves to the original set of boxes. So that's fine. That's totally fine. So really what we want to do here is confine ourselves to the original box count. Like so. All right. Okay, so now we're at least running. We're totally wrong. This is not a good lighting solution. But that's fine for today. So next weekend will be our debugging festival. And we can get the rest of this stuff working. But now we don't have any of that sort of really nasty bookkeeping in there that I was uncomfortable with. I just didn't feel like it was going to go particularly well for us. So now what we've got is, okay, entities can store the information about their lighting in them while they're still in a place where it's going to matter. As soon as we detect that they've gone too far out of there, we can jettison it. So that's part of the entity packing and repacking stuff when we put that in later on in the game's life cycle. And so that will be the place where that can happen. And now we just store that information directly back into the entity. So when an entity puts its graphics information into the world, it also puts its lighting information if that lighting information existed on the previous frame. And if it didn't, it didn't. We don't care. We recompute it, right? So that's way saner than it was, and I'm pretty happy with it. All right. I'll go to like the briefest of Q&As, so only completely on-topic questions. If there's a very on-topic question, I will take it. Otherwise, no. The 148 million was the number of cycles I took. Ah, okay, great. So I see no really on-topic questions. Is this your usual design process, a bit ad hoc? Well, it depends what you mean by design process. That's not really a very specific term and doesn't refer to anything. In terms of trying to develop new algorithms, obviously, yes, you have to be exploratory. So you have to try things and see what works. Once you're done with them, then you can maybe talk about a design process, which would be, we know exactly what we're doing, and now we're going to design, say, an API for it or something like that. Or design exactly how we want the system to function in a shipping sense, which is a different thing. So there's two kinds of design. There's exploratory design and there's like shipping design. Exploratory design has to be ad hoc because you obviously don't know what you're doing or you wouldn't have to be exploring a solution. Whereas something where you're done, you're like, this is what it is. And now we just want to make it be sort of ready, packaged up and, designed for maintenance and that sort of stuff. That's a different process. All right, looks like no further questions. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org. It comes with the source code so you can play around with it. I'm going to be back to debug this stuff next week. I'm pretty happy with what we decided to do with the caching there. That's a lot saner than where we were going before, so I think that's going to work out better in the long term, but we've got a bunch of debugging and performance optimization to do now, so we just got to roll up our sleeves and do that, and I think we should be in good shape. So I hope that you come back to join me for that. I may only do one stream next weekend because I may have prior engagement one of the days. So either way, we will start the debugging next weekend, though I just don't know if it'll be 2 days, it might only be 1 day. Either way, that's what we're going to be doing, so hope to see you back here for that. Till then, have fun programming, and I'll see y'all on the internet. Take it easy, everybody.